Okay, so now we're going to talk about empirical formula. First, we want to talk about what is empirical formula. Empirical formula, as a definition, is the lowest whole number ratio of elements in a compound. Now, you're saying, Miss Nichols, what does that actually mean in layman's terms, right? How can I understand that sciencey definition? What that means is when we have a compound, for example, C2H5, when I look at my subscripts, the 2 for carbon and the 5 for hydrogen, I know that I cannot reduce those numbers anymore, which means that C2H5 is the empirical formula. But if I had a compound that said C4H10, I know that I could reduce the 4 and the 10 by dividing by 2 in order to get to C2H5. So I would say that C2H5 is the empirical formula for C4H10. So it's just telling you the lowest ratio of your elements. It's not necessarily the exact number, but it's the lowest ratio. So in problem number 1, you're just giving the decimal numbers of these fractions, okay? And the problem I'm actually going to work through is problems number 3 and 4, okay? In problem number 3, it says find the empirical formula of a compound that contains 53.70% iron and 46.30% sulfur. And actually, before we begin, I forgot one amazing thing. We have a nice little rhyme that will help us remember the steps to calculating empirical formula. So what we're going to do right now is we're going to write this rhyme at the top of our paper so that we'll have it as we're working through the problems. And the rhyme goes like this. Percent to mass, mass to mole, divide by small, and multiply till whole. So there are 4 lines to this rhyme, and there are 4 steps to calculating empirical formula. So we will go ahead and use that. It should be written at the top of your paper or somewhere in your notes. We're going to use that rhyme to help us solve problems 3 and 4. I'm actually going to erase it so that I have all of my room now. Okay. So number 3, again, they give us 53.70% iron and 46.30% sulfur. And in the same way that we were doing our mole conversion problems, we find what's given and what we're looking for. We're given certain percentage of iron and sulfur, and they're trying to have us find the empirical formula. So these are the things that are given and what we're looking for. So in our rhyme, the first step says percent to mass. Now, when we convert from percent to mass, what we do is we drop the percentage sign and we put a gram sign instead. So 53.70% iron becomes 53.70 grams of iron. And the reason why we do this, there's actually a reason, is because if we assume that we have 100 grams of this compound, because they don't tell us how much I actually have, if I assume that I have 100 grams, then I know that 53.70% of 100 is going to be 53.7. So we assume a 100 gram sample to start with so that we can make our life easier. So the first step is fairly easy. We get rid of the percent sign and put a gram sign instead. So 46 0.30% becomes 46.30 grams of sulfur. So, we have completed the first step. The second step says mass to mole. So now that we are in mass, in grams, we need to convert both of these values into moles. And we know how to do this by using our molar mass. We know that molar mass can take us from grams of iron into moles of iron. So if we look at our periodic table, the mass of iron is 55.85 grams. And if I look on the periodic table for sulfur, I'll see that sulfur has a mass of 32.07 grams, and it's always equal to 1 mole of that substance. So when we put this in our calculator, we say 53.70 divided by 55.85, we get 0.96 moles of iron, and 46.30 divided by 32.07 gives us 1.44 moles of sulfur. So we have now converted from grams of each of our elements into moles of our elements. We have just completed the second step. The third part of the rhyme says divide by small. So what we do is we look at the number of moles we have and we pick the smallest number. So 0.96 is smaller than 1.44, so I'm going to divide both of my values by the smallest number. I'm going to divide by 0.96 moles here, and divide by 0.96 moles here. When I do that, I know that 0.96 divided by 0.96 is going to give me 1. 1.44 divided by 0.96 is going to give me 1.5. We have just completed step number 3. The last and final line of the rhyme says multiply till whole. Now when we multiply till whole, what this means is that the answer we have cannot be a fraction or a decimal number. And that's because these numbers are how many atoms we have. Right now I have 1 atom of iron and 1.5 atoms of sulfur. But you cannot have half of an atom. You can only have 1 atom or 2 atoms. You can't have 1.5. So this means we need to think of a number that we can multiply by both of our compounds to where both of them will be whole numbers. So if I look at 0.5, I realize that 0.5 is the same thing as 1/2. And 1/2 has a 2 in my denominator. So if I think about it, if I multiply 1.5 by 2, I'll get the number 3, which is a whole number. So that is the number that I'm going to want to multiply by. And because I multiplied sulfurs by 2, I also need to multiply the top one by 2. So now I have completed my step, and the last thing is to just write it as a formula. So I'll say that I have 2 atoms of iron and 3 atoms of sulfur. So my empirical formula is iron with 2, so Fe2S3, and I box in my answer. Let's try problem number 4. Problem number 4 says an analysis of a 10.150 gram sample of a compound known to contain only phosphorus and oxygen indicates a phosphorus content of 4.433 grams. What is the empirical formula of this compound? So they're asking us for the empirical formula, and they give us in the problem 4.433 grams and 0.0150 grams. Now, 4.433 grams is for phosphorus. 4.433 grams of phosphorus. And they tell us in this compound that it contains phosphorus and oxygen. But they don't tell us how much oxygen we have. However, they do tell us that the entire compound weighs 10.150 grams, which means that if I subtract 10.150 minus the amount of phosphorus I had, which was 4.433, that can give me the amount of oxygen I have. So when I put that in my calculator and calculate the amount of oxygen I have 5.717 grams of oxygen. So even though they did not come right out and tell it to us, they did give us the means to be able to calculate the grams of oxygen. So let's follow our same steps. Now you will notice because they did not give us percentages, we can skip the percent to mass step. Because we're given grams, we're going to start at line 2 of the rhyme that says from mass to mole. So let's convert our 4.433 grams of phosphorus into moles of phosphorus and our 5.717 grams of oxygen into moles of oxygen. Now, the molar mass of phosphorus, when you look at the periodic table, is 30.97, and the molar mass of oxygen is 16. So when you plug these into your calculator to convert, we say 4.433 divided by 30.97, we get 0.14 moles of phosphorus. And 5.717 divided by 16 gives us 0.36 moles of oxygen. So we have converted from mass to mole, and our next step is divide by small. 0.14 is the smallest number, so I'm going to divide both numbers by 0.14. I know that this will give me 1, and 0.36 divided by 0.14 is going to give me 2.5. Okay, 2.5 is a decimal number, which means that I'm going to need to multiply. So if I multiply this, I'm going to multiply it by 2 in order to get 5. I'm going to multiply this by 2 in order to get 2. I needed to follow the last rhyme, which said multiply to a whole, so that I could get the whole numbers 2 and 5. And now all I have to do is write my final answer, P2O5. And that will be the empirical formula. If you have any questions about empirical formula that I did not answer during the video, or another question about a different problem, please come see me before or after class.